In this video, we're going to be talking about a few applications of exponential functions and logarithms. First one being exponential growth. Here's your formula for exponential growth. F of t is equal to a times 1 plus r raised to the t power, where a is your initial amount. So you start at 5, start at 6, whatever. That's your starting amount. R is the rate of growth. Maybe something's growing by 5% or by 10%. And then T is the time or the amount of time at which it grows. Here's an example. The original value of an investment is $18,000. If the value has increased by 7% each year, write an exponential function to model the situation. So it's growing by that 7%. So our function looks like this. F of t, it's going to start at 1,800. And it's going to grow at a rate of 7%, which that would be 0.07. Now, in this parentheses, 1.07, because here's why. The 1 is for this reason. It grew by 7%, so it is now bigger than what it used to be. It's 100% of what it used to be plus an additional 7%. So that's what this actually is. It is now 107% of what it used to be. And then you're going to do raised to the t power based on how many years. After 1 year, it would be 1,800 times 1.07 would be how big it is. After 2 years, you're going to multiply by 1.07 twice. So if that's my function, then find the value of the investment after 15 years. So we're finding f of 15. So that'd be 1,800 times 1.07. We're going to multiply by 1.07 15 times, and that's going to give us $4,966.26. Number 2, in 2002, there was 972 students enrolled at Oakview High School. Since then, the number of students has increased 1.5%. It's exponential growth there each year. Write an exponential function to model the situation. Then find the number of students enrolled in 2014. So our function is going to be, we're going to start with 972 students, and we're growing at a rate of 1.5%. So it is now 100. If you take the 100% or 1 and add that 1.5 to it, we're now at 101.5% each year of what we were before. So again, that's going to be anytime you plug a percent into a formula, you always change it to a decimal form. So when we do 1 plus r, we're doing 1 plus 0.015, which is now this, raised to the t power. So now this is kind of tricky. In 2002, there were 972. We're going to let this be our time equals 0. That's our starting time. So therefore, in 2014, that would be 12 years later. So that'd be t equals 12. So we're finding f of 12 in years. So we're going to do 972 times 1.015 raised to the 12th power, and we're going to get 1,162 students. Now, this actually is a decimal answer, but it's going to be hard to have a decimal student, so therefore we're going to round to the nearest whole student. Exponential decay now. Given by the formula, f of t is equal to. Now, this occurs when a quantity exponentially decreases over time. So you've got to be careful with the percentage. Now, if something decreases, let's say decreases by 5%. Well, it used to be 100%. If it decreases by 5, it is now at 95%. So that's the reason in this formula, we're going to start at A, and we're going to multiply by a rate of 1 minus R, to where R is the percent that it's going down, raised to the t power. So again, A is the initial amount, or amount that you're starting with. R is the rate of decrease. And then, of course, T would be, again, time. So an investment starts at 12,000, but it's losing value. It's going down 4% each year. So it was 100%, but if it goes down 4%, you're now at 96% of what it used to be. Write an exponential function to model the situation. So f of t is equal to, you started at 12,000. However, you're losing 4%. So you're going to do, in here, it's 1 minus r. And if R is 4%, that's 0.04. So that's going to be a 0.96. Now, I just wanted to show you where that came from, raised to the t power. So again, if it's after 1 year, you're going to find 96% of 1200. After 2 years, you're going to find 96% of that again. After 3 years, 96% of that again. So we're finding out after 9 years. So we're finding f of 9, which would be 12,000 times 0.96 to the ninth power, and that's going to give you $8,310.41. Okay, number 4 says Mark bought a brand new car for $35,000 in 2008. The car depreciates. That means it loses value at approximately 8% each year. So it's going down 8%, again, 0.08 each year. Write an exponential function to model the situation. So your function is it starts at 35,000. However, after 1 year, it is now 92% of what it used to be. It goes down 92% of what it was before each year, so raised to the t power. So we're finding out in 2015, so this would be year 1, or excuse me, year 0. That's where you're starting. So 2009 would be year 1, and so on and so forth. So this would be year 7. That'd be 7 years later. So we're finding f of 7. So be careful not to let this be your first year, because in 2008, a year has not passed yet. That's your 0 year. So we're going to do 35,000 times 0.92 to the 7th power. And what that's going to do is going to find 92% 7 times. And we're going to get a final answer of 19,524 and 63 cents. So the car has nearly depreciated to half of its value after those 7 years. Compound interest, new formula. This occurs when interest is calculated on both the principal and the accrued interest. So you can think of it like this. You invest a pile of money. And when you invest money, it earns interest the longer that you leave it in the bank. However, we would really like for our interest to earn interest. So the process of compounding interest is actually taking the amount of interest that you earn and putting it into your big pile of money and letting it earn interest as well. We'll go ahead and write the formula first. Then it is A is equal to P times 1 plus R over N raised to the NT power. Now, I've already started talking about N. This whole process of accruing interest. N is the number of times that you're going to compound each year. The number of times compounded each year. So if you're going to compound your interest twice a year, that means halfway through the year, you're going to take the interest that you've earned and your bank is going to put it with your pile of money. Then at the end of the year again, that second time, it's going to take the amount of interest that you earn and it's going to put it with that money. If it compounds interest monthly, that means 12 times a year. Every month is taking the amount of interest that you've earned and putting it with your principal that you invested. And that's what P stands for. P is your principal. P is the money that you actually invested. Principal. There we go. And that's actually supposed to be AL. The amount of money that you invested, or we can put it's our initial amount. That's your starting amount. R is your interest rate, and T, of course, is your time. So if Laura deposits $12,000 into an account that earns 8% interest, $12,000 is the initial amount. It's earning 8% interest. How much money will she have in 5 years? That's your time. If the interest is compounded quarterly. Quarterly means 4 times a year. So your end value there is going to be 4. So all you're doing here is you're plugging everything in. The amount of money that you're going to have is equal to, we're going to do 12,000 times 1 plus, the rate is 8%. Make sure you change it to a decimal. It's compounded 4 times a year. We're going to raise that to the n times t power. So that would be your n is 4, your t is 5. So you can just raise it to the 20th power if you like. You can type this all straight into your calculator, or if you're going to do it by steps, make sure you divide first. Then you're going to add 1 to do the stuff in parentheses. Then you raise it to the 20th power. Then you multiply it by 12,000, and you're going to get 17 $831 and 37 cents. So your money has grown from 12,000 to nearly 18,000. Jack took out a 6-year loan for $25,000 to purchase a boat at a 4.5% interest rate. If the interest is compounded monthly, so since it's monthly, that would be 12 times a year. What will he have paid over the course of the loan? So A is equal to P times 1 plus R over N raised to the NT power. The initial amount of the loan was $25,000, and it's a 6-year loan, so that tells you the T. So let's plug everything in. $25,000 loan. Now he's borrowing money. In the last one, we were actually depositing money, so you got to be careful here. So the 1 plus the interest rate would be 0.045, and that's going to go in for the R, 0.045 over. It's a 6-year loan, and we want to know over the course of the loan how much he's paying. Raised to the NT power, so that would be 6 years times N, which is a 72nd power. Again, to do this step by step, you would divide, then you would add 1. That's everything in parentheses. You would then raise it to the 72 power, multiply it by 25,000, and you would get $32,732.58. Make sure that you can type that in, and that's the answer that you would get. Number 7 says an investment account pays 3.9% interest, compounded semi-annually. Semi-annually means that it's twice a year. If $4,000 is invested in the account, what is the balance after 12 years? A is equal to P times 1 plus R over N raised to the NT power. We want to know how much is going to be in there after 12 years if $4,000 was invested. That's your initial amount. 1 plus the rate is 0.039 over, let's see, the N would be 2, then raised to the N times T power. Now, if you were to want to type this straight into your calculator, again, you would use the caret button, but make sure that you put N times T in parentheses, that you do 2 times 12 also in parentheses, so you get the correct answer. And after those 12 years, I get an answer of $6,358.48. Number 8. A savings account offers 0.8% interest compounded bi-monthly. Bi-monthly would be twice every month. So in a year, that would be 24 times. So my N here would be 24. Bob deposits $300. How much interest will he earn after 10 years? So you got to be careful because they're being tricky on how they're asking this question. Savings account offers, your interest rate would be 0.008, would be 0.8%. So A is equal to P times, I'm going to go ahead and write the whole formula again, raised to the NT power. Your principal, you are depositing $300. 1 plus the rate would be 0.008. The N was 24. Raised to the 24 times, we're doing it for 10 years power. Again, you can either type the whole thing in or do it step by step, and you're going to get $324.98. Now, there's a problem with that answer because it says how much interest will he earn. He invested $300. He now has this much money. 300 of that was the investment. So the actual amount of interest that he has earned is only the $24.98. Again, $300 was the initial investment, so you have to take that off to see how much interest his account has earned. Number 9. Suppose you invest $750 into an account that pays 3% interest, 0.03, compounded weekly. So weekly would be there are 52 weeks in a year, so therefore N is 52. How much interest will you have earned after 20 years? A is equal to P times 1 plus R over N raised to the NT power. So that would be your principal would be $750. 1 plus your rate is going to be 0.03 over the N is 52 raised to the 52 times 20 power. Plug that in and you're going to get 1366, 35, And again, you have to be careful because your initial investment was already $750. So you're going to have to take that, take away 17 or 750, and that's going to leave you with $616.35, I believe. And that's your final answer.